Welcome to the Industrial Classroom, and today's topic is belt speed calculation and motor selection. In the previous video, we learned about calculating the length of the belt roll. But what about when we consider the belt speed and which type of motor or which motor should we select? For this, let us now start today's topic. See, whenever we are diving into belt speed calculation and how that speed dictates your motor selection, if you are engineer or plant operator, getting this math wrong means burning out your motors or shredding your belts. Now, how fast is your belt moving and is your motor strong enough to keep it that way? First, let us come to a point of calculation of the linear speed. Okay, so when we are talking about we are taking it as the linear speed or the okay, it's the linear speed of the belt or the speed at which the belt is moving. So these are the pulleys. Let us consider. One is this is the drive pulley and this is the tail pulley. So the speed at which it is moving, it is the linear speed. So according to the formula, we know that pi into d into n by 60 is equal to linear speed, where pi is equal to constant, or we call it as 3.1416. D is the OD of the drive pulley. Okay, so this is the value of D if this is the drive pulley, and then we have N, that is rotation per minute, RPM. It is taken in, or we can say it is N is the RPM. Okay, rotation per minute. So we have this formula, V is equal to pi into D into N into 60. This will give the linear speed of the belt. Now let us take an example. Okay, so here we see that if the pulley diameter is 500 mm, so let us consider this pulley diameter. This is 500 mm. Okay, or we can say it is 0.5 meter. Then motor or gearbox speed is equal to 60 rpm. Let us say that the motor is rotating at a speed of 60 revolutions per minute or 60 rotations per minute. Okay, so in 1 minute it is covering 60 rounds. Okay, so now we know that formula, linear velocity is equal to pi into d into n by 60. So what is pi here? Pi is equal to 3.1416. Then d is equal to 500 mm and n is equal to our 60 divided by 60. Okay, so here we see that 60 will be cut out, and 3.14 into 5 70 and 5 3s are 15. Okay, so 15.7 15 70 and 100. Here we will be 15700 millimeter per second, since we have taken it as mm. Now to convert it into meter, what we do, we will remove these 4 zeros. 15 5 70 00, right? Son, millimeter and meter. Did we do it all correct? It is 500 mm and 3.14, 570, 5 is 15, 15.70, 15.70. So it will be 15 so here it will be equal to 5.7 meter per second. So this is the correct thing that we are having right now. So here we find that the linear velocity is equal to 1.57 meter per second. So here we know that whenever we come to the selection of the motors, the important factor is the power. Larger power means larger motor. Remember, larger motor or the larger gearbox. Okay, so power which we know is equal to the tension here. Okay, the effective tension, TE, is nothing but effective tension of the belt. Okay, TE. Then V is equal to linear speed 1000 into F. N is equal to efficiency. So generally in cases we know that T is equal TE into V divided by 1000 into efficiency. See, TE is the belt tension, V is equal to the meter per second or the effective tension, the linear velocity, 1000, and N. Efficiency, we consider it as 0.85 to 0.9 in case of gearboxes. Okay, remember. So this is the formula for the power. And also remember the fact that speed isn't everything. Okay, so remember that speed isn't everything. What we need to know that an important form is the torque. Okay, the power which it generates, the torque, right? So whenever we calculate P is equal to effective tension into, here we linear velocity divided by 1000 into N. Okay, this power which multiplied by 1.15 to 1.2. Why? Because there is some starting torque which a motor which a motor provides. Okay, a starting torque. So the gearbox must be sufficient to accompany that torque. Okay, therefore there is a starting torque which is much more heavier, about 20% to about 15% to 20% more than the general torque. Therefore we multiplied with, so what we got, that the effective power is equal to 1.15, or we consider it as 1.2 into this power. So this is the minimum power of the motor which you should have. Hope you understood this. So for the example, what we get here, 1.57, we will multiply. Here you can do it 0.85. The tension of the belt is in Newton. You can consider it something around 800 Newton. Okay, you can consider it an example and you can calculate the power. After calculating the power, multiply it with 1.2, then you get the effective power of the motor. And with this power rating you must go to the electrical shop and then you can buy that motor. Okay, in you will get it in kilowatt and you can buy that capacity motor. Okay, so this will be enough. Where in the next, in the some other video, we will learn about calculating the effective tension. It is also very much important. Right now, this for today. Thank you.